somewhere out there, right now, someone is reading something online about their blood type. Maybe they just got a lab result back, or they donated blood for the first time, or they stumbled down a rabbit hole at 2 a.m. the way you do, and they've landed on a claim that stops them cold, something like, Rh negative blood is not fully human, or people with Rh negative blood have no evolutionary explanation, or this is the bloodline of ancient gods, of fallen angels, of beings that were not born on this planet. And the strange thing is, once you read something like that, it's hard to shake. 2 letters, R and H. And suddenly, a whole mythology has wrapped itself around your biology. Tonight we're going to follow that thread all the way back. Not because the wild theories are true, and I'll tell you plainly right now that they aren't, but because the real story behind Rh blood is genuinely fascinating. Quietly, almost secretly fascinating. The kind of fascinating that doesn't need ancient aliens to be worth losing sleep over. And if you are losing sleep over it tonight, well, that's literally why I make these. So settle in. Before we go anywhere, tell me where you're listening from and what time it is there. I check every comment, and it's one of my favourite things, honestly. It's midnight in Melbourne and 3 p.m. in Montreal, and someone in a small Norwegian town is just about to fall asleep with their cat on their feet. Drop your location and your local time in the comments. It helps more than you know. And if you want to hear this without any ads, without any background music, just a voice in the dark, come find the channel on Spotify. It's completely free to follow. There are no ads, no music layered underneath, just the story. The link is in the description. It genuinely supports the work, and I'm grateful every time someone clicks it. Now, back to the blood. Rh. 2 letters that have become, in certain corners of the internet, a kind of shorthand for otherness, for specialness, for mystery. And the reason they've attracted so much myth, so much speculation, so much breathless late-night theorizing is actually a little ironic. Because Rh negative blood isn't rare in any alarming sense. It isn't poorly understood by science, and it certainly isn't evidence of anything supernatural, but it is interesting, and that's enough. Interesting things attract stories. Stories, left unchecked, sometimes drift a long way from the facts. What we're going to do tonight is trace that drift. We're going to start at the very beginning, with what blood meant to ancient people, long before anyone had a microscope or a test tube or any concept of blood type at all. We'll move through the slow, sometimes brutal history of how humans learned what blood actually is, how it circulates, what it's made of, and what happens when you give someone the wrong kind. We'll get to the discovery of blood groups in the early 20th century, the kind of discovery that quietly saved millions of lives without anyone making a movie about it. We'll meet the arch factor properly, learn where it came from, and what it does, and why it matters in medicine, especially in pregnancy. And then we'll look honestly at the genetics, at the populations where Rh negative appears more frequently, and why, without pretending there's something coded or conspiratorial hidden in the numbers. And then, because you can't talk about Rh negative blood without eventually arriving there, we'll look at the myths, the royal bloodline theory, the extraterrestrial origin theory, the Nephilim, the Watchers, the idea that certain humans carry genes that don't belong to this world. We'll look at where those ideas came from, how they spread, and why they feel so compelling even when the evidence just isn't there. Because the feeling of being special, of having an origin that connects you to something ancient and unknown, is a very human feeling. And it's worth understanding, not mocking. The truth is that negative blood has a real history, a real science, and a real human drama attached to it. Mothers and newborns, transfusion disasters, decades of medical detective work. People whose lives were saved and people who were lost before anyone understood what was happening. That story doesn't need embellishment, but embellishment came anyway, as it always does when something's unusual and the explanation feels too ordinary. So that's what tonight is. It's a quiet investigation, an honest one. We'll follow what is actually known, we'll be careful about what is merely suspected, and we'll be clear when we're talking about something that was simply invented, however appealing it might sound. There's a particular kind of satisfaction in this kind of story. Not the satisfaction of a shocking reveal, but the slower, warmer kind that comes from understanding something properly. From holding a real thing in your hands instead of a rumour. And each blood, when you actually look at it closely, is a real thing worth holding. The path ahead is a long one and a calm one. We'll pass through ancient Egypt and the Roman world. through the early modern physicians who argued about the soul in the blood, through the first terrifying transfusion experiments in 17th century Europe, through the quiet laboratory in Vienna where a man named Karl Landsteiner changed medicine forever at the turn of the 20th century. We'll spend time with the scientists who found the Rh factor, who named it after the wrong animal as it turned out, and who slowly pieced together why certain pregnancies were going wrong in ways no one could explain. We'll look at maps, at populations, at what it actually means that Rh-negative blood shows up more often in some parts of the world than others. And we'll do all of that before we ever get to the myths. Because the myths make more sense, and are easier to see clearly. Once you know the real thing, they grew around. There's no rush tonight. That's the whole point of this. The night is long and the story is long and you don't have to be anywhere. You can just listen. If you fall asleep before we get to the Nephilim, good. That means the episode did its job. The story will still be here when you come back. And if you're still awake at the end, leave me a comment. Tell me where you're listening from. Tell me what time it is where you are. Blood is one of the oldest subjects in human thought. Older than writing, older than philosophy, older than most of what we call civilization. And two letters, R and H, found their way to the edge of all that history, and acquired a weight they were never quite meant to carry. Let's find out how. Long before anyone understood what blood actually was, people understood that it mattered. You didn't need a theory to know that. You just needed to watch. Watch a person take a wound. Watch the colour leave their face. Watch what happens when enough of it spills onto the ground and doesn't stop. Life and blood were, for most of human history, essentially the same thing. Not metaphorically, literally. If the blood stays in, the person stays alive. If it leaves, they don't. The logic was right there in front of you, written in every hunt, every battle, every difficult childbirth. So it isn't surprising that blood became sacred almost everywhere humans settled and left records. What's worth sitting with is just how early that happened, and how consistently, across cultures that had no contact with each other, blood arrived at the centre of the same kinds of meaning. In ancient Mesopotamia, in the texts that survive from Sumer and Babylon, blood was the substance used by the gods to create human beings. The Atrahasis myth, which is one of the oldest creation stories we have, describes humans being formed from clay mixed with the blood of a slain deity. Not breath, not light, not stone. Blood. Because blood was what the divine had that mere clay did not. It was the animating ingredient. The thing that turned matter into life. And that belief, in various forms, shows up so widely across ancient cultures that historians have largely stopped being surprised by it. It seems to be something humans reach for almost independently when they start asking why living things are different from dead ones. Egypt treated blood with similar gravity, though in a more complicated way. Egyptian medical and religious texts show a culture that recognized blood as carrying something essential, something connected to what we might loosely translate as vital force. They didn't separate the spiritual from the physical in the way later Western thought would come to do. The heart, which was considered the seat of mind and feeling, was understood to work in concert with blood moving through the body. When Egyptian priests prepared animals for sacrifice, the management of blood was not incidental. It was central. The blood had to go somewhere specific, had to be handled in specific ways, because the power contained in it was real and had to be properly directed or it could cause harm. Across the ancient Near East more broadly, blood sacrifice was the primary language of communication between humans and gods. Not the only language, but the primary one. Temples were, among other things, places where blood was managed and offered. Animals, and in some cultures and periods, humans, were killed not out of cruelty, but out of a very earnest understanding that the divine required something irreplaceable, and nothing was more irreplaceable than life itself. Blood was life, offered back to the source of life. The logic was internally coherent, even if it makes us uncomfortable to look at directly. The Hebrew tradition preserved a version of this so thoroughly that it shaped the entire subsequent history of Western religious thought. The injunction against consuming blood, repeated across Leviticus and Deuteronomy, wasn't arbitrary dietary law. It was rooted in a precise theological position. Blood was where life resided. To consume blood was to consume something that belonged to God, not to human beings. The famous verse is explicit about it. The life of the flesh is in the blood. That single line carries a weight that echoes across millennia. It established blood not just as a symbol of life, but as its literal vehicle, and it set up categories of purity and contamination that would shape how people thought about identity, lineage, and belonging for thousands of years afterward. Those purity categories matter more than they might initially seem. Once blood becomes the carrier of life and the marker of divine favour, the question of whose blood is what, and whether blood can be mixed, contaminated, made impure, follows quite naturally. And here is where the symbolic logic of ancient blood beliefs begins to do something with lasting consequences. It begins to code for identity, for group membership, for who belongs and who doesn't. In ancient Rome, blood oaths were among the most binding commitments a person could make. Soldiers swore on blood. Alliances were sealed with it. The mixing of blood between individuals was an act of brotherhood, of mutual obligation so serious it superseded most other loyalties. Blood literally meant family, and family meant survival, and survival was not something Romans took lightly. When we use phrases like blood oath or blood brothers today, we're carrying a remnant of this, something that was once very concrete and very serious, now softened into metaphor but still faintly resonant with its original weight. What's interesting, from the vantage point of this story we're telling, is that actual biological understanding of blood remained essentially absent from all of this rich symbolic activity. Ancient people were making enormously precise observations about what blood did, how it behaved, what happened when you lost it or mixed it or withheld it from a sacrifice. But their framework for understanding what it was, what made it do what it did, was entirely metaphysical. The power they were observing was real. The explanations they built for it were, by our current understanding, entirely wrong. And that gap between the real observation and the framework built around it is one of the oldest gaps in human intellectual history. You see something true, you reach for the explanation. The explanation feels right, coheres with everything else you believe, satisfies the emotional need to understand, and so the explanation becomes doctrine before anyone has actually tested it. That's not a flaw unique to ancient people. We'll see it again much later in this story in contexts that feel a great deal more modern. Meanwhile, the taboos multiplied. Menstrual blood was separated into its own category of power and danger in nearly every ancient culture, treated simultaneously as potent and contaminating, something that required ritual management precisely because it was not ordinary. Blood from wounds was different from sacrificial blood, was different from the blood of childbirth, was different from the blood of the dying. Each category carried its own rules, its own ritual requirements, its own symbolic load, and underneath all of it was a shared assumption that blood was not merely a fluid, it was a carrier, a vehicle for something essential that couldn't be located or named precisely, but whose presence was obvious and whose absence was final. The Greeks inherited all of this, filtered it through their particular love of systematic explanation, and began building something that would eventually lead, through many centuries and many dead ends, toward actual biology. Hippocrates and the medical tradition he represents didn't abandon the idea that blood carried something vital. They tried to systematize it. Blood became one of the four humours, the life-giving one, the one associated with warmth and vitality, and the season of spring. This was still metaphysics dressed in the language of medicine, but it was a step toward treating blood as something that could be reasoned about, categorized, described in terms that weren't purely divine. That step, small and incomplete as it was, matters. We'll follow it further in the next section. But for now, stay here for a moment with the larger picture. What you have, across these ancient cultures, spanning thousands of years and multiple continents, is an almost universal human intuition that blood is special in a way that nothing else quite is, that it carries life, that it carries identity, that it can transmit qualities from one person or creature to another, that its purity can be compromised, and that such compromise has consequences, that some blood might be in some sense different from other blood, more powerful, more sacred, closer to the divine. None of that was scientific, but it wasn't random either. It was the human mind doing what the human mind does, observing something real, something genuinely important, and reaching for meaning, building frameworks that let communities manage and share and transmit that meaning. And those frameworks, once built, are remarkably durable. They don't disappear when better explanations come along. They go underground, they transform, they attach themselves to new language and new contexts. They resurface, sometimes centuries later, wearing different clothes, speaking a different vocabulary, but carrying the same ancient emotional weight. When someone reads today that Rh negative blood is the blood of a special lineage, of people marked out by ancient origin or divine connection, they are, without knowing it, reaching back into something very old, a pattern of thought about blood that was already ancient when Rome was young. The specific claims are modern, the structure underneath them is not. And that's not an accident, and it's not stupidity. It's something more human than either of those things. We'll come back to that much later when we have the full picture in front of us. For now, let's follow where the actual science went, because the road from sacred offering to blood type is a long one and a strange one, and some of the strangest parts come surprisingly early. The Greeks had already decided what blood was before they had any real way of finding out. That's not a criticism. It's just what happens when observation is sharp but tools are absent. You see the body, you see what enters it and what leaves it. You watch what happens when it's injured or ill or dying. You build a framework that makes sense of all of that, and then, because the framework is elegant and it works well enough for most purposes, it becomes the framework. For a very long time, the system that Hippocrates and his successors put together, refined across several generations and eventually codified most influentially by Galen in the 2nd century, organized the body around 4 substances: blood, phlegm, yellow bile, and black bile. Each humour was associated with particular qualities, particular organs, particular seasons, particular temperaments. Blood was warm and moist, generated in the liver, associated with vitality and optimism. The other 3 existed in relationship to it, complementing it, balancing it, tipping the whole system into illness when they fell out of their proper proportions. What strikes you, looking at this from a distance, is how internally consistent it all was. The humoral model wasn't built on random guesswork. It was built on genuine observation, just observation conducted without the tools that would have been necessary to see what was actually happening. Ancient physicians watched blood change colour when exposed to air. They noticed that sick people often looked pale or flushed or jaundiced, in ways that seemed to correspond to different qualities in the blood. They observed that bloodletting sometimes appeared to help certain patients and concluded, reasonably enough given what they had to work with, that restoring balance between the humours was the mechanism of recovery. The observations were real. The explanatory framework mapped onto them convincingly, and so the framework survived, not for decades but for more than 1,000 years, across cultures that absorbed Greek medical theory and built their own traditions on top of it. Galen's version of humoral medicine became particularly durable because Galen was both brilliant and prolific. He wrote an enormous amount. He had access to dissection in ways that many of his predecessors did not, and he was confident in his conclusions in a way that tends to either attract or repel followers, but rarely produces indifference. His description of how blood moved through the body was detailed and coherent, and almost entirely wrong. In his account, the liver constantly produced new blood from food, and that blood moved outward through the veins to nourish the tissues, which consumed it rather than returning it. A separate, more refined form of vital spirit moved through the arteries. The 2 systems were largely separate. Blood didn't circulate in any sense we would recognize. It was more like an irrigation system, a one-way flow from source to consumption. This model persisted through the medieval period in both European and Islamic medical traditions, which inherited Greek texts through complex chains of translation and commentary. It wasn't unchanged. Medieval physicians in both traditions read carefully, added their own observations, and debated the details among themselves. But the basic architecture held. Blood was made. Blood moved outward. Blood nourished. That was the story. Somewhere in 13th century Cairo, a scholar named Ibn al-Nafis wrote a commentary on Avicenna's Canon of Medicine that included a description of something Galen had not accounted for. He argued that blood moved from the right side of the heart through the lungs to the left side, rather than passing directly through pores in the septum as Galen had claimed. His reasoning was both anatomical and logical. He had looked at the heart. He could find no such pores. He concluded that the blood must take a different route, and he described what we now call pulmonary circulation with considerable accuracy. This was a genuine insight, reached through careful observation and willingness to contradict an established authority. What's worth noting, without overstating it, is what happened next. Ibn al-Nafis worked within a tradition that revered Galen, but was not incapable of questioning him. His commentary circulated in Arabic medical scholarship. It influenced later thinkers, though the exact paths of influence are still debated by historians of science. His work is sometimes cited as an early landmark in the story of circulation, which it is, though the road from his insight to a comprehensive circulatory model was neither straight nor simple, and involved many other thinkers working in different contexts across several centuries. That's how science usually works, not as a sequence of lone geniuses, but as a slow accretion of ideas meeting the right conditions at the right moments. By the early 17th century, those conditions had changed substantially. Anatomy had become a respectable discipline with its own institutions and instruments. Dissection was more common, more systematic, more openly discussed. The printing press had transformed how medical knowledge moved between scholars, and a physician named William Harvey, working in England, began a series of experiments and calculations that would break the humoral model's hold on how people understood blood. Harvey's approach was methodical, in a way that feels distinctly modern. He measured, he calculated. He asked how much blood the heart pumped with each beat, multiplied that by the number of beats per hour, and arrived at a figure that was simply incompatible with Galen's model. If the liver were continuously producing all this blood and the tissues were continuously consuming it, the body would need to manufacture and dispose of an absurd quantity every single hour. The numbers didn't work. Something else had to be happening. What Harvey proposed instead was circulation in the full sense. The same blood moving continuously pumped by the heart outward through the arteries and returning through the veins in an unbroken loop. He published his account in 1628 in a relatively short book called De Motu Cordis, and it was not immediately embraced by everyone. Established frameworks rarely go quietly. There were critics who found the idea difficult to accept, colleagues who defended the old model, readers who thought Harvey had gone too far in one direction or not far enough in another. But the evidence was substantial, and the reasoning was careful, and over the following decades the circulatory model became the foundation of European medicine. What Harvey couldn't do yet was see the mechanism connecting arteries to veins at the smallest scale. He knew the connection had to exist, but the technology to observe it wasn't quite there. It was only after his death, with the development of more powerful microscopes, that Marcello Malpighi described the capillaries, those tiny vessels that complete the circuit. The picture finally closed. Blood moved in a loop, through structures that could be named and observed and eventually measured. This mattered enormously for what would come next, though it didn't lead there immediately. Once blood was understood as a physical system, as a fluid moving through defined structures on a continuous path through the body, the questions you could ask about it changed. Before Harvey, blood was a humour, a substance with qualities that could be adjusted by adding or subtracting it from the body. After Harvey, blood was a circulating fluid whose properties might vary between individuals, might be altered by disease, might potentially be transferred from one body to another with real physical consequences. That last possibility, transfer between bodies, was both exciting and alarming, and it led, within just a few decades of Harvey's publication, to some of the most earnest and most catastrophic experiments in the history of medicine. Physicians began asking whether you could put blood from one creature into another, and what would happen if you tried. The answers came back quickly and were deeply instructive, though not in the way the experimenters had hoped. But to get to that part of the story properly, it helps to stay here a moment longer with what the shift in understanding actually meant. What Harvey and those who followed him had done wasn't just correct a technical error. They had changed the fundamental nature of the question. Blood was no longer primarily a symbolic or spiritual substance whose properties were about balance and vitality in a metaphysical sense. It was a biological fluid whose behavior could be studied, whose composition might be analyzed, whose movement could be measured. It existed in the physical world in a way that could be investigated rather than simply assumed. And that shift, from assumed to investigated, is what eventually made it possible to discover that blood differed between individuals, not because of divine favour or lineage in some mystical sense, but because of specific, describable, physical properties. Properties that would turn out to be inherited, distributed unevenly across populations, and occasionally relevant to medicine in ways both serious and strange. The tools to find those properties didn't exist yet. Microscopes were still crude, chemistry was in its infancy, genetics as a discipline was more than 2 centuries away, but the orientation had changed. People were now, at least in principle, looking at blood rather than simply believing in it. The experiments that came next were not careful or successful. They were, in fact, fairly disastrous. And they're worth knowing about because they reveal something important about the distance between having the right general idea and knowing enough to make it work. The right general idea arrived before the right knowledge to support it. That gap between a reasonable hypothesis and the understanding needed to act on it safely is one of the recurring features of medical history, and it tends to be measured in lives. Within a few decades of Harvey's publication, physicians in England and France began thinking seriously about what transfusion might accomplish. The logic was, on its surface, coherent. If blood circulated continuously through defined structures, and if illness often seemed to correlate with some deficiency or corruption of the blood, then perhaps the solution was to replace that blood, or supplement it, or dilute whatever was wrong with it by introducing blood from a healthier source. The idea had a kind of elegant simplicity that made it appealing to experimenters who were still working out what blood actually was. The first attempts didn't involve humans at all. In the 1660s, researchers began with animals, which was both practical and, in a grim way, revealing. Richard Lower, an English physician, successfully transfused blood between dogs, keeping a recipient animal alive after draining much of its own blood by connecting it to a donor through silver tubes. The experiment worked more or less, at least often enough to seem promising. Lower and others took this as encouraging. It suggested the basic mechanics were feasible. Blood could be moved from one body to another through physical means. The circulatory model had made that imaginable, and now it had been demonstrated. What followed from this fairly quickly was the obvious next step. Transfusion between species. Jean-Baptiste Denis, a French physician working in Paris in 1667, became one of the first to attempt transfusion from an animal into a human patient. His reasoning was not entirely irrational by the standards of the time. Animal blood, he thought, might be purer, less corrupted by the vices and imbalances that afflicted human constitutions. He used lamb's blood, which had an additional layer of symbolic appeal given its associations with gentleness and purity. His first patient survived. His second also survived, at least initially. Denis transfused small amounts, probably small enough that the recipient's own immune system managed the insult without catastrophic response. He announced his results with considerable enthusiasm, and for a brief moment it seemed as though a genuine medical breakthrough was at hand. Then patients began to die. A third patient of Denis, a man named Antoine Maurois, received multiple transfusions and died shortly after the final one. Denis maintained that poison was involved, that enemies had arranged the death to discredit him. This claim was investigated and the charge against him eventually dismissed, but the damage to the practice was significant. The death raised exactly the fears that any unexplained fatality in an experimental context tends to raise, particularly when the experiment is already surrounded by public unease. People in the late 17th century weren't entirely comfortable with the idea of blood from one creature being introduced into another. It sat uncomfortably against existing ideas about what blood meant, what it carried, what kind of thing a person might become if their blood were mixed with an animal's. Both France and England moved to restrict transfusion within a few years. The French Parliament passed regulations requiring medical faculty approval before any such experiments could be conducted. In England, the Royal Society, which had been enthusiastic about the early experiments, grew more cautious. The practice largely disappeared from respectable medicine for well over a century, not because the idea was abandoned forever, but because it had accumulated enough failures and enough deaths, and enough controversy to make it untenable, without better understanding of what was actually happening inside the body when the blood of one creature entered another. What nobody knew, and couldn't have known with the tools available, was that blood was not a uniform substance. It looked similar enough between individuals that this assumption was easy to hold. It was red, it moved, it clotted when exposed to air. These properties seemed consistent. What was invisible, completely beyond the reach of 17th century observation, was the biochemical surface architecture of individual blood cells, the molecular differences that would eventually be named and described and mapped. The idea that blood from one person might be simply incompatible with blood from another, not because of moral or spiritual contamination, but because of specific physical properties that differed between individuals, was not something that could be arrived at through observation alone. It required a level of biological chemistry that hadn't been developed yet. The disasters were real, but they couldn't be properly explained. When interest in transfusion revived in the 19th century, it came back in a somewhat more systematic form, but still without the crucial piece of knowledge that would have made the practice safe. James Blundell, an English obstetrician working in London in the early 1800s, turned his attention to transfusion because he had a specific clinical problem. Women were dying of hemorrhage after childbirth, and Blundell thought that replacing lost blood was a more logical response than any other treatment available to him. He also recognised, which was an important step forward, that human blood should be used for human recipients rather than animal blood. His reasoning was sensible. The species barrier, at least, was worth respecting. Blundell performed a series of transfusions through the 1820s, and his results were mixed in ways that, in retrospect, tell the whole story. Some patients recovered. Others died or suffered severe reactions. Blundell recorded his outcomes carefully and honestly, which is itself worth noting, and he acknowledged that the procedure was unpredictable. He couldn't understand why it worked sometimes and failed catastrophically at others. He suspected air in the tubing, or some technical issue with the equipment, or variations in the condition of the patients. He kept refining his apparatus, designing new instruments for transferring blood more safely. What he couldn't see was that the failures and the successes didn't track technical factors. They tracked something invisible inside the blood itself. This pattern continued through the 19th century. Transfusion was attempted. Sometimes it helped, sometimes it killed, and the difference seemed almost random. The practice was never fully abandoned, but it was never fully trusted either. It existed in a kind of limbo, promising in theory, unreliable in practice, and deeply frightening to patients and practitioners alike when things went wrong. Wartime had a particular way of driving medical experimentation forward regardless of uncertainty, because the alternative to an imperfect treatment was often no treatment at all. The Franco-Prussian War of 1870, and later the conflicts of the late 19th and early 20th centuries, created conditions where physicians had both the urgency and the volume of patients needed to observe transfusion outcomes in larger numbers. Military surgery was, in this grim sense, a kind of laboratory. Techniques developed under battlefield conditions fed back into civilian medicine. The failures accumulated alongside the successes, and the pattern of unpredictability became more visible, even if its cause remained obscure. By the early 20th century, the basic mechanism of why transfusions sometimes failed was still unknown. The problem wasn't technique. It wasn't infection, though infection was a real concern. It wasn't the equipment or the timing or the amount. The problem was compatibility, a concept that didn't yet have a name or a scientific framework. Blood from one person introduced into another could trigger a cascade of responses inside the recipient's body that had nothing to do with any visible property of the blood. The red cells could clump together, clog vessels, break apart, release substances that the kidneys couldn't process quickly enough. Patients would develop fevers, chills, pain in the back and chest. Sometimes they recovered. Sometimes they went into shock and died. The body was rejecting something, recognizing something as foreign, mounting a response against it. But what that something was, how to predict it, how to test for it before attempting a transfusion, how to match donors to recipients in a way that avoided these reactions entirely. That understanding was still waiting to be discovered. It was sitting in the blood itself, written in the surface of every red blood cell in every human body, a molecular language that no one could yet read. That was about to change. Not dramatically, not all at once, but through the kind of careful, patient laboratory work that tends to look inevitable only in retrospect. The answer, when it came, would be both simpler and more consequential than anyone had expected, and it would arrive at the hands of a researcher who wasn't primarily looking for it. Karl Landsteiner was an Austrian physician working in Vienna at the turn of the 20th century, and what he was primarily interested in was immunology, the way the body recognizes and responds to foreign substances. Blood transfusion was not exactly his focus. He arrived at the discovery the way many important discoveries are made, by following a methodical observation to its logical conclusion and being careful enough not to dismiss what he found as error. In 1900 and 1901, Landsteiner was working in a modest laboratory at the Vienna Pathological Institute, and he began noticing something that the previous century of transfusion disasters had somehow never pinned down clearly. When he mixed blood serum from one person with red blood cells from another, the cells sometimes clumped together, forming small visible clusters. Sometimes they didn't. The reaction wasn't random. It followed a pattern. Specific samples clumped with specific other samples, and the same combinations produced the same results every time he tested them. This clumping, which had a technical name, agglutination, was predictable, and predictability meant there was something real to understand. What Landsteiner had found was that human blood came in distinct types, and that each type carried its own molecular markers on the surface of its red blood cells. He identified 3 groups initially, which he called A, B, and C. A colleague later renamed C to O, and a 4th group, AB, was identified the following year by 2 of Landsteiner's collaborators. The naming has always been a little awkward for newcomers to the subject, but the biology beneath it is genuinely straightforward once you have the key. Think of it this way. The surface of every red blood cell is covered in proteins and sugars, and among these are specific molecular structures called antigens. Whether your red cells carry one particular type of antigen, or another type, or both, or neither, determines your ABO blood group. If your red cells carry the A antigen, you are type A. If they carry the B antigen, you are type B. If they carry both, you are type AB. If they carry neither, you are type O. That's the whole system at the cell level. The more important detail, the one that made transfusion history dangerous, involves what's happening in the liquid part of the blood, the serum, at the same time. The immune system, it turns out, produces antibodies against whichever ABO antigens your own body does not carry. If you are type A, your serum contains antibodies against B antigens. If you are type B, you carry antibodies against A. Type O, carrying neither antigen, produces antibodies against both. Type AB, carrying both, produces neither. This is the reason transfusion reactions happened. When blood from a type A donor entered a type O recipient, the recipient's immune system recognized those A antigens as foreign and launched a response. The antibodies bound to the donated red cells, causing them to clump and break apart, triggering the chain of reactions that produced fever, pain, shock, and sometimes death. The body wasn't malfunctioning. It was doing exactly what it was built to do. It was defending itself against something it had been designed to detect as not belonging. Every mysterious death, every inexplicable recovery, every pattern of transfusion working sometimes and failing catastrophically at others, all of it traced back to this single underlying fact. Blood was not uniform, it came in types. Whether a transfusion succeeded depended entirely on whether donor and recipient happened to be compatible. Before Landsteiner, that compatibility was left entirely to chance. After Landsteiner, it could be tested. Before a transfusion, you took a small amount of the donor's blood and a small amount of the recipient's and mixed them in a controlled way, watching for agglutination. If the cells clumped, you chose a different donor. If they didn't, you proceeded. The test took minutes. The implications were enormous. Transfusion mortality rates dropped sharply once ABO typing became standard practice in the years following the discovery, and particularly after the First World War, when military medicine had both the scale and the urgency to implement blood typing systematically. For the first time in the long, troubled history of blood transfusion, the procedure became something that could be reliably predicted, planned, and made safe. Landsteiner received the Nobel Prize in Physiology or Medicine in 1930, 30 years after the initial discovery, which is itself a kind of reflection of how slowly even genuinely transformative scientific work can be recognized. He would later contribute to identifying the Rh factor as well, which is the part of this story we'll come to shortly, but the ABO system alone would have secured his place in medical history. It was one of those discoveries that seems, in retrospect, almost painfully simple. A pattern that had been hiding in plain sight through a century of preventable deaths, waiting for someone systematic enough to notice it, and careful enough to follow it through. What happened next, in the years following the discovery, is slightly less flattering to the history of science, and worth touching on gently because it rhymes with things that are still happening today. Once, ABO blood groups became widely known, and the idea of blood coming in distinct biological types became part of public awareness. A fairly predictable thing occurred. People began looking for other differences that might correlate with blood type. If blood types were real and meaningful biologically, perhaps they were meaningful in other ways too. Perhaps they tracked personality or temperament or aptitude. Perhaps the type of blood you carried said something about the kind of person you were. The most elaborate version of this thinking developed in Japan, where by the early 20th century, researchers and writers were exploring the idea that ABO blood type predicted character traits. Type A individuals were said to be organized, cautious, and sensitive. Type B was associated with creativity and self-absorption. Type O was linked to confidence and leadership. Type AB was considered the most complex, carrying traits of both. These associations became embedded in popular culture in ways that have proven remarkably durable. In Japan, asking someone their blood type as a way of understanding their personality is still common enough to have its own cultural vocabulary. The European version was darker. In the 1920s and 1930s, some researchers in Germany attempted to connect ABO blood group distributions across populations to ideas about racial hierarchy, trying to use blood type frequencies as a biological argument for distinctions they had decided to make for other reasons entirely. This line of inquiry is a clear example of what correlation hunting looks like, when it is driven by a conclusion someone has already reached, and it deserves to be named as such. Both versions, the personality typing and the racial science, share the same underlying problem. ABO blood groups are real. The molecular biology is real. The medical consequences of incompatibility are real, but none of that reality extends into predictions about character, intelligence, temperament, or the relative worth of human populations. Blood type tells you about antigens on red cell surfaces and the corresponding antibodies in serum. It doesn't tell you anything about what kind of person someone is, or what they're capable of, or how they relate to any other group of people. The lesson is worth holding on to, not because the people who pursued these associations were necessarily malicious, though sometimes they were, but because the pattern recurs. A genuinely interesting biological phenomenon gets discovered. The phenomenon is real and important, and then, almost immediately, people begin loading it with additional meaning, looking for correlations that confirm things they already believe or want to believe. The phenomenon becomes evidence for almost anything, because once you are selectively looking for connections, they are not hard to find. ABO blood types had been discovered. They were transforming medicine. They were saving lives. And they were also, within a few decades of Landsteiner's first publications, being drafted into service for ideas that had nothing to do with blood cells and everything to do with the human tendency to want categories to mean more than they do. That tendency is something to keep in mind as we move forward, because it's going to come up again. Landsteiner himself continued working, and in 1937, alongside a colleague named Alexander Wiener, he identified another antigen on the surface of red blood cells, a different one, with a different inheritance pattern and its own set of medical consequences. It would eventually be named after the rhesus monkey used in some of the experiments, and it would carry, over the following decades, an even heavier load of projected meaning than the ABO system ever had. The name itself is worth pausing on, because it has caused a surprising amount of confusion over the decades, and that confusion is not entirely innocent. When Karl Landsteiner and Alexander Wiener announced their findings in 1937, they named the newly identified antigen after the rhesus macaque, a small monkey commonly used in laboratory research. The experiments involved injecting red blood cells from rhesus monkeys into rabbits and guinea pigs, which then produced antibodies against those cells. When those same antibodies were applied to human blood samples, they reacted with the red cells of most people, but not all. Whatever the rabbit antibodies were recognizing, most humans had it and some didn't. The researchers named the antigen accordingly. What followed, over the next several years, was a tangle of independent discoveries, competing nomenclatures, and laboratory cross-reactions that took decades to fully sort out. It turned out that Landsteiner and Wiener's rhesus antibody was not quite the same as another antibody that other researchers were identifying around the same time through a different clinical route, one involving actual human patients and actual transfusion reactions. The antigens involved were related but not identical. The naming, however, had already happened. ARSH had become the label that stuck, and the minor molecular distinction that would technically distinguish Wiener's original antigen from the one now understood as the primary Rh factor was quietly folded into the background of the nomenclature, relevant to specialists and largely invisible to everyone else. This is the kind of thing that happens in science when discoveries arrive in parallel from different directions before anyone has a clear enough view of the whole picture to settle on consistent terminology. The practical name that emerged from all of this was simple enough. There is a specific protein, now understood as the D antigen, that can be present on the surface of red blood cells or absent. If it is present, you are Rh positive. If it is absent, you are Rh negative. That's the foundation of it. The D antigen is the most clinically significant member of a larger family of related proteins, and when people in ordinary conversation refer to Rh factor, they're almost always referring specifically to this one antigen. The broader Rh blood group system is considerably more complex, containing dozens of distinct antigens, but the presence or absence of D is the variable that carries the most medical weight, and it's the one that shows up on blood type cards when someone is described as A positive or O negative. At the level of the red blood cell, what you are looking at is a protein embedded in the cell membrane. Red blood cells are not simple smooth spheres. Their surfaces are studded with a remarkable variety of proteins and sugars, and these surface molecules are what the immune system uses to determine whether a cell belongs to the body or not. The D antigen is one such protein. In people who are Rh positive, it is present and expressed on the cell surface. In people who are Rh negative, the gene that codes for it is either absent or non-functional, and the protein is simply not made. There is no antigen there to be detected. This isn't a matter of having a weaker version of the protein or a mutated form that functions differently. It is, in the most straightforward sense, a presence or an absence. The reason Rh mattered even after ABO typing had transformed transfusion medicine was that ABO compatibility alone was not sufficient to prevent all transfusion reactions. Physicians and researchers in the late 1930s and early 1940s were still encountering cases where a patient had been transfused with ABO-compatible blood and still developed a reaction, sometimes a serious one. The ABO system had explained the majority of historical transfusion disasters, but not all of them. There was something else going on in some patients, and identifying that something else required looking at the blood more carefully than the existing framework allowed. What they found was that a person who is Rh negative can, under the right circumstances, develop antibodies against the D antigen if they are exposed to Rh positive blood. The immune system of an Rh negative person has never encountered the D protein. It isn't present in their own blood, so there has been no reason to recognize it as self. When Rh positive red cells enter their bloodstream, whether through a poorly matched transfusion or through another route, the immune system may eventually treat the D antigen as foreign and mount a response against it. This response doesn't always happen after a single exposure, and it doesn't always happen at all, but in a significant number of cases it does, and once it has happened once, the immune system remembers. A second exposure to Rh positive blood in someone who has already developed anti-D antibodies can produce a reaction that is severe and sometimes fatal. This explained a category of transfusion reactions that ABO typing had failed to prevent. It also explained something else, something that had nothing to do with transfusion at all, and which turned out to be the most clinically significant consequence of the Rh system in everyday human life. But that is the next part of the story. What is worth noting here before moving on is the way the laboratory work surrounding Rh discovery accumulated its own layers of complexity without any of the individual researchers intending to create confusion. Landsteiner and Wiener, the immunologist Philip Levine working largely in parallel, the clinical physicians observing patients and reactions that didn't fit the ABO framework. They were all approaching the same underlying biology from different angles, using slightly different experimental materials, producing slightly different antibodies in their test animals, and naming what they found according to where they were standing. The result was a nomenclature that has never been fully resolved, a set of overlapping terms that experts use with precision and that everyone else tends to blur together. The rhesus monkey is still there in the name, a small vestige of an early experiment that slightly misrepresents the actual molecular relationship between monkey and human blood. The monkey connection was incidental. The antigen is a distinctly human protein with a distinct pattern of inheritance. But the name, once given, proved impossible to dislodge. This is not a trivial observation. Names carry weight. When a blood type is named after a primate, when that blood type is described as being either present or absent in a way that clearly distinguishes two groups of people, and when the details of how that naming happened are not widely known, a space opens up in which people begin asking whether the name means something more than it does, whether the absence of a particular protein might indicate a different origin, whether one group might be more or less connected to some lineage that the other group lacks. These questions start from the name and then work backward, finding the biology that seems to support whatever story has already been imagined. It is important to say clearly that the name reflects the history of a laboratory experiment. Rabbits were injected with rhesus monkey cells. The antibodies that rabbits produced happened to react with a protein found on most human red cells. The protein was named accordingly. That chain of events tells you nothing about the evolutionary history of the protein, about any relationship between humans and rhesus monkeys, beyond the incidental one of a shared antigen, or about the meaning of being positive or negative for that antigen, in any sense beyond the strictly biochemical. What the Rh system actually explains is something more grounded and, in its own way, more interesting than any of the stories that have been constructed around it. It explains a specific and well-characterized aspect of human immunology, a pattern of antigen expression that varies across individuals and populations for reasons that genetics can trace quite precisely. It creates a medically meaningful difference between Rh positive and Rh negative individuals in certain very specific circumstances, and it is expressed differently across different human populations in ways that reflect real evolutionary history. Though not the kind of history the myths tend to describe, that evolutionary and population story is worth getting to carefully and slowly. But before it, there is another chapter of the Arch story that is more personal, more immediate, and in many ways more dramatic than anything the laboratory work alone could produce. It involves what happens when an Rh negative mother carries an Rh positive child, and it is one of the genuinely compelling dramas in the history of medicine. Consider what happens when a child inherits something from their father that their mother's immune system has never encountered. Not a disease, not an infection, just a protein. A single protein on the surface of red blood cells that one person carries and another doesn't. Under most circumstances, this difference is invisible. It causes no symptoms, produces no illness, creates no tension between the two people. But under one very specific set of circumstances, inside the body of a pregnant woman, that difference can become a matter of life and death for the child she's carrying. This is the story of hemolytic disease of the fetus and newborn, and it is not a story about conspiracy or ancient bloodlines or beings from elsewhere. It is a story about biology working exactly as biology works, about an immune system doing precisely what immune systems are designed to do, about the collision between two closely related but immunologically distinct human beings sharing the same blood supply for 9 months. It is documented in medical records going back generations. Its mechanisms are understood at the molecular level. The outcomes before prevention were measurable and deeply human in their cost, and the eventual resolution of that cost is one of the more quietly remarkable achievements in the history of medicine. The mechanism itself, described without any clinical instruction, works roughly like this. When an Rh negative mother carries a child who has inherited Rh positive blood from its father, there is a mismatch between what the mother's immune system recognizes as self and what is present in the fetal circulation. During pregnancy, and particularly during delivery, small amounts of fetal blood can cross the placental barrier and enter the mother's bloodstream. When that happens, the mother's immune system encounters the D antigen for the first time, and in many cases it responds. It generates antibodies. It learns to recognize the D protein as something foreign, something to be targeted. In a first pregnancy, this sensitization typically occurs late enough that the child is not seriously affected. The antibodies are only beginning to develop, but in a subsequent pregnancy, if that second child is also Rh positive, the mother's immune system already knows what the D antigen looks like. The antibodies she develops the first time can cross the placenta. They can enter the fetal circulation, and once there, they attach to the D antigen on the fetal red blood cells and mark those cells for destruction. The fetal immune system cannot stop this. The antibodies come from the mother, small enough to cross the placental barrier, and the fetus simply does not have the resources to counter them. Its red cells are destroyed faster than they can be replaced. The resulting condition, in its severe forms, meant profound anemia, organ failure, and death, either before birth or shortly after. The historical record carries the weight of how common this was before anyone understood what was happening. Physicians had known for a long time that certain families seemed to suffer a pattern of infant deaths that followed a specific shape. First children survived. Subsequent children were sometimes born pale and swollen, jaundiced, barely alive, or not alive at all. The families were not unusual in any visible way. The mothers were healthy, the fathers were healthy. There was no apparent infection, no obvious cause. The pattern simply repeated itself across pregnancies, and for generations no one could explain why. The clinical understanding that something immunological was happening developed gradually through the 1940s, building on the same laboratory work that had identified the Rh factor in the first place. Philip Levine, working somewhat separately from Landsteiner and Wiener, was among the first to connect Rh incompatibility to fetal death and newborn illness. He was looking at cases of severe transfusion reactions in women who had previously been pregnant, and he noticed that the antibodies causing those reactions were the same kind as the ones appearing in mothers whose infants had died. The connection between the two phenomena, transfusion reactions and infant death, turned out to share the same underlying mechanism. Both involved an Rh negative person who had been exposed to Rh positive blood and had developed anti-D antibodies as a result. Once the mechanism was understood, the question became what to do about it, and for a period of decades the answers were partial and expensive in human terms. Blood transfusions could be given to severely affected newborns to replace damaged blood with compatible blood. Exchange transfusions, where the infant's blood was systematically replaced over a period of time, became a standard response in severe cases. In the most extreme situations, physicians attempted transfusions before birth. Each of these interventions was technically demanding, and each carried its own risks. They helped. They saved lives that would otherwise have been lost, but they were responses to a problem that was already underway, not solutions to the underlying cause. The more fundamental shift came through the development of what is now understood as Rh immunoglobulin, a treatment given to Rh-negative mothers following delivery or other potential exposure events to prevent the sensitization from occurring in the first place. The logic of it is straightforward enough to describe in general terms. If the mother's immune system can be prevented from recognizing and responding to the D antigen when fetal cells first enter her bloodstream, the antibodies that cause the damage in future pregnancies will never develop. The treatment introduced in the 1960s did exactly this, intercepting the initial immune response before it could be established. Within years of its widespread adoption, the rates of hemolytic disease in newborns dropped dramatically in populations where the treatment was accessible. A condition that had claimed an enormous number of lives across human history, without anyone understanding why, became largely preventable. This arc from mystery to mechanism to prevention is the kind of story that medicine rarely tells as cleanly as it happened here. The biology was genuinely difficult to see. The connection between a mother's immune memory and a subsequent child's survival required putting together observations from transfusion medicine, obstetrics, and laboratory immunology that were being gathered in different rooms by different people. When those observations finally converged, the picture that emerged was precise and actionable. What makes the Rh story so worth dwelling on, in the context of all the mythology and speculation that has grown up around Rh-negative blood, is that the actual documented story is more remarkable in its own way than any of the invented ones. No ancient mystery is needed to make Rh significant. The significance is already there, written in hospital records and epidemiological data, and the case histories of families who suffered repeating losses without any explanation available to them. The real story involves molecular biology that wasn't understood until the mid-20th century, a clinical pattern that was observed for generations before anyone could explain it, and a medical intervention that changed outcomes across entire populations in a measurable and documentable way. That's not a lesser story because it has a scientific explanation. It's a more compelling story for being true. There is also something quietly humbling about the mechanism itself, about the fact that an immune system operating exactly as it should, doing nothing unusual, nothing aberrant, nothing that could be called error, can under very specific circumstances work against the survival of a new generation. The mother is not ill, the child is not infected. The antigen involved is a normal human protein carried by the majority of the population. What creates the conflict is simply the combination of genetic inheritance, molecular recognition, and timing. Biology producing a kind of tragic mismatch from elements that are each individually unremarkable. This is worth keeping in mind as the story continues. The distribution of Rh-negative blood across human populations, the question of why some groups carry it at higher frequencies than others, why it appears at all, what its presence and absence might tell us about human history. These are genuinely interesting questions. The genetics of Rh, properly understood, reflects real evolutionary history, real population movements, real patterns of ancestry and divergence that researchers have been working to document for decades. But before moving into that population story, it seemed important to spend time here, with the clinical one, with the families who didn't know why their children were dying, with the researchers who pieced the mechanism together over years of painstaking laboratory work, with the quiet transformation that followed. The story of Rh negative blood, at its most human, is not a story about alien ancestry or royal bloodlines. It's a story about a protein, a pregnancy, and what it took to finally understand the connection between the two. So now that we understand what Rh negative blood does in the body, and what happens when it meets Rh positive blood under the right circumstances, the next natural question is where it comes from. Not in the conspiratorial sense, not in the sense of hidden origins or suppressed knowledge, but in the plain genetic sense. How does Rh status pass from one generation to the next? Why does the pattern sometimes surprise people? And what do the frequencies we see across different human populations actually tell us about our shared history? The answers are genuinely interesting. They involve real evolutionary mechanisms, real patterns of human migration and population history, and real ongoing scientific uncertainty in places where the data hasn't yet settled into consensus. None of it requires supernatural explanation. All of it rewards careful attention. Start with the basic inheritance. The Rh system at its core involves a gene called RhD. Rh-positive individuals carry at least one functional copy of that gene, which produces the D antigen on the surface of their red blood cells. Rh-negative individuals, in the most common version of the story, have a deletion, meaning the RhD gene is simply absent from both copies of the relevant chromosome, not mutated in a way that produces something new and strange, but missing. A stretch of DNA that is present in most people simply isn't there. This matters for understanding inheritance patterns because of how it plays out across generations. The Rh trait is inherited in a broadly recessive pattern, which means that to be Rh negative, you need to have inherited the deletion from both parents. A person who inherits a functional RhD gene from one parent and a deletion from the other will be Rh positive, because one working copy is enough to produce the D antigen. But they carry the deletion silently, and they can pass it on. This is why two Rh positive parents can have an Rh negative child. Both parents were carrying the deletion on one chromosome without expressing it, and the child inherited the deletion from both of them at once. From the outside, if you don't know the genetics, this can look like something appeared from nowhere. From the inside of the mechanism, it's completely ordinary. Recessive inheritance operating exactly as recessive inheritance always operates. The word mutation tends to carry weight it doesn't always deserve. When people hear that Rh negative blood results from a genetic mutation, the word sometimes implies something aberrant, something introduced from outside the normal course of things. But in the strict biological sense, mutation simply means a change in a DNA sequence that persists across generations. Deletion, insertion, substitution, these are all forms of mutation, and they happen constantly in every genome across every generation. Most have no effect whatsoever. Some are harmful. A few turn out to be neutral or even advantageous under certain conditions. The absence of the RhD gene is one change among millions of changes scattered through the human genome accumulated over hundreds of thousands of years. There is no evidence that it was introduced by any external agent, ancient or otherwise. There is no indication in the molecular data that it is anything other than what genomic comparison suggests it is, a deletion that arose, spread to some degree in some populations, and has been carried forward through normal human reproduction ever since. When you look at why Rh negative frequencies vary so much across populations, you find yourself looking at processes that population geneticists have documented across dozens of different traits. One of the most relevant is founder effect. When a small group of people splits off from a larger population and establishes itself somewhere new, the genetic variation in that founding group may not represent the full variation of the population it came from. If the founders happen to include a higher than average proportion of people carrying the RhD deletion, then the population that descends from them will carry it at higher frequency too. Not because the deletion was selected for, not because it conferred any particular advantage in that environment, but simply because of which people happen to be among the founders. This kind of demographic accident is well documented in human genetics. It leaves signatures that researchers can read in the structure of genomes, in patterns of genetic diversity, in the relative frequencies of particular variants across related populations. Genetic drift is a related process. In small populations, chance plays a larger role in which variants persist and spread, and which ones disappear. A version of a gene that is genuinely neutral, that neither helps nor harms its carrier, can still increase in frequency over many generations just through the random variation in who reproduces and who doesn't, who survives long enough to pass on their genes and who doesn't. Over thousands of years, in populations that were sometimes very small and geographically isolated, drift alone could account for substantial differences in the frequency of Rh-negative blood between groups. There are also selection hypotheses, though these are more contested. Some researchers have proposed that Rh-negative status might have offered some kind of advantage in certain environments, perhaps some degree of resistance to particular pathogens, perhaps some benefit that has not yet been clearly identified. The honest answer is that no strong selective advantage for Rh-negative blood has been convincingly demonstrated to date. The hypotheses exist, the research continues, and the current state of the evidence is genuinely uncertain. That uncertainty is not a gap where speculation should rush in. It's simply an area where the science hasn't finished its work yet, and responsible discussion means acknowledging that openly, rather than filling the space with confident claims in either direction. What the population data does show, quite clearly, is that Rh-negative frequencies vary enormously across human groups. The variation is real. It has a genetic basis. It almost certainly reflects the history of those populations, where they came from, how large or small they were at critical periods, how isolated they were from neighbouring groups, whether they passed through bottlenecks or founding events that shifted the proportions of various genetic variants. Reading that variation as a map of human migration and population history is legitimate and ongoing scientific work. Reading it as evidence of separate biological origins, as some popular accounts suggest, is not supported by the data. Modern genetic analysis tests claims about human diversity slowly and carefully, with attention to sample sizes, with awareness of the ways that geographic structure can create patterns that look dramatic but have mundane explanations, and with a consistent willingness to revise conclusions when better data becomes available. This is not a weakness in the scientific method. It's the method working exactly as it should. The alternative, committing firmly to explanations before the evidence is adequate, tends to produce conclusions that later need to be walked back, and that in the meantime can cause real harm by misleading people about what their own biology means. One thing genetics has made quite clear is that there is no single Rh-negative population with a unified ancient origin distinct from everyone else. Rh-negative individuals are distributed across the human species, connected by shared ancestry with Rh-positive individuals everywhere, carrying the same major population histories in their genomes as their Rh-positive relatives. The deletion that produces Rh-negative status is found in multiple forms in different populations, suggesting it may have arisen more than once independently, which is itself a sign that it is not a single ancient event, but something that has happened in the course of normal human genetic history. The genetics of Rh then tells a story about population structure, about inheritance patterns that can surprise people who encounter them without the underlying framework, about mutations as ordinary events rather than extraordinary ones, and about the value of sitting with real scientific uncertainty rather than replacing it prematurely with cleaner and more dramatic narratives. The distribution of Rh-negative blood across human populations is a genuine subject of ongoing research. The results of that research so far point toward explanations rooted in population history, in the movements and contractions and expansions of human groups across thousands of years. The same forces that shaped every other dimension of human genetic diversity. Not special, not hidden, but genuinely, quietly fascinating if you're willing to follow where the evidence actually leads. So let's follow the evidence out into the world. Let's look at the actual distribution of Rh-negative blood across human populations, and ask what that distribution genuinely shows, and equally importantly, what it doesn't. The numbers themselves are striking enough to invite curiosity without needing any embellishment. In parts of Western Europe, particularly among Basque populations in the Pyrenees region between Spain and France, Rh-negative frequency reaches somewhere around 30 to 35%. That's unusually high. In most of sub-Saharan Africa, the frequency drops to roughly 1 to 3%. Across East Asian populations it falls even lower, sometimes to less than 1%. In the Middle East and South Asia, you find intermediate values, somewhere in the range of 5 to 10% depending on the specific group being studied. North and South American indigenous populations, prior to European contact, had frequencies approaching 0 in most communities. These are real differences. They are documented in the scientific literature. They reflect genuine biological variation across human groups. And they are interesting precisely because they tell us something about history, not the history that internet videos tend to suggest, but the actual layered, complicated, migration-shaped history of human beings moving across the surface of the planet over thousands of generations. Start with the Basque case, because it comes up constantly, and it deserves careful treatment. The Basque people have long been recognized as genetically unusual in several respects, not just in Rh negative frequency, but across a broader range of markers. For a long time, this was interpreted as evidence that they were a remnant of Europe's original pre-agricultural population, people who had been in Western Europe since before the Great Migrations that reshaped the continent's genetic landscape in the Neolithic and Bronze Age. The Basque language, which is not related to any other living language, added weight to this interpretation, and there's something to it. Modern genomic analysis does show that Basque populations carry higher proportions of ancestry associated with Europe's hunter-gatherer past than many of their neighbours. But the story's more complicated than it first appears. Later waves of migration did reach the Basque region. The isolation was never total, and the elevated Rh negative frequency almost certainly reflects a combination of founder effects, genetic drift in a relatively isolated population, and the simple mathematics of what happens when a particular genetic variant is present at above average frequency in a founding group that then reproduces with limited outside mixing for many generations. It amplifies, not because something special was happening, but because isolation and small effective population sizes allow chance to shape gene frequencies in ways that larger, more connected populations don't experience as strongly. This is the same logic that explains low Rh negative frequencies elsewhere. East Asian populations descend from groups that expanded across Asia and eventually reached the Americas, populations that went through their own bottlenecks, their own founding events, their own particular histories. If the RHD deletion happened to be rare or absent in the populations that founded those lineages, then the descendants of those founders will also carry it rarely or not at all. That's not a mark of difference in origin. It's a mark of which genetic variants happen to be common or rare in which ancestral groups at critical moments in migration history. Ancient DNA research has started to add real texture to these questions, though it also comes with important limitations. Researchers can now sequence genetic material from skeletal remains tens of thousands of years old, and in principle, this should allow us to track when and where various genetic variants, including those related to Rh status, were present in past populations. In practice, the picture is still fragmentary. Ancient DNA preservation is uneven. Sample sizes are often small, representing particular sites and time periods rather than whole populations. And not all ancient remains have been analysed for the specific variants relevant to blood type. What ancient DNA can do is give us a clearer picture of population movements, of which groups replaced or mixed with which other groups, and of how the genetic composition of regions changed over time. What it cannot yet do is hand us a complete map of historical Rh frequencies across all human populations across all periods. The data is growing, the techniques are improving, and the picture will sharpen over time. But right now, anyone claiming that ancient DNA has definitively revealed the origins of Rh negative blood in some ancient and separate lineage is outrunning what the evidence actually supports. This is where sampling bias becomes an important concept to understand because it shapes a great deal of what circulates as online lore about Rh negative blood. The maps that appear in documentaries and forum posts and YouTube videos often look authoritative. They show Rh negative frequency spreading outward from Western Europe, darkening in the Basque region, fading as you move east and south. They look like they're telling a coherent story about an origin point and a direction of spread. But those maps are only as good as the data that built them, and the data is not evenly distributed. Certain populations have been studied extensively, others have been sampled rarely or not at all. When you shade a map based on incomplete sampling, you create visual patterns that can mislead. Gaps in data look like absences of the trait. Well-sampled regions dominate the picture, and the resulting image gives a false impression of clarity about a distribution that is actually more complicated and more nuanced than any simple map can convey. Cherry-picked data makes this worse. If you want to tell a story about Rh-negative blood originating in a particular place or belonging to a particular group of people, you can find fragments of real data that seem to support your story if you're selective enough about which numbers you cite and which you ignore. This is not how population genetics works when it's done carefully, but it is how a persuasive-sounding narrative can be assembled from real statistics without those statistics actually supporting the conclusion being drawn. The Basque frequency is real. The low frequencies in East Asia are real. But fitting those numbers into a story of separate ancient origins requires ignoring the broader genomic context that situates Rh negative individuals within the same human family as everyone else, connected by the same migration events and the same ancestral populations carrying the same overall genomic architecture. A grounded way to look at Rh frequency data starts with acknowledging what the variation actually reflects. Human populations have different histories. They experience different bottlenecks, different expansions, different periods of isolation and contact. Any neutral or nearly neutral genetic variant will have drifted to different frequencies across those populations simply as a consequence of those demographic histories. Rh status is one such variant among thousands. When you map it, you are essentially mapping a partial echo of population history, and that echo is interesting, genuinely interesting, the way all of human prehistory is interesting, because it connects us to movements and events that happened long before anyone was writing them down. What it doesn't do is sort humanity into distinct ancient lineages with different origins. The genomic evidence for that claim doesn't exist. What does exist is a richly complicated map of human migration, intermingling, isolation, and reconnection that shaped every aspect of human genetic variation, including the frequencies of blood-related traits. Rh. Negative blood is woven into that story the same way everything else in the human genome is woven into it, not as an anomaly pointing toward hidden origins, but as one thread among billions in a fabric that took hundreds of thousands of years to weave. The populations with high Rh negative frequencies are connected by history to the populations with low frequencies. The genetic distances between groups, when measured properly across the whole genome, rather than cherry-picked at a single locus, reflect the patterns of migration and divergence that archaeologists and historians recognize. Nothing in that picture requires a special explanation, but sitting with the real picture, letting it breathe, following the actual movements of actual human populations across actual landscapes and actual time, that turns out to be quietly extraordinary on its own terms. And understanding that the real story holds up without embellishment is actually important, because there are embellishments waiting just around the corner, and they have been waiting for a long time. The embellishments, it turns out, are not new. They didn't arrive with the internet. They didn't begin when someone made their first conspiracy video or posted their first forum thread about ancient astronauts and genetic memory. The impulse that drives them is much older than any of that, old enough to qualify as one of the most durable features of human storytelling, which is the desire to believe that certain bloodlines carry something more than biology. This desire runs so deep in human culture that it almost feels instinctive, and in some ways, it probably is. The same social instincts that helped our ancestors navigate complex group relationships, that told them to pay attention to kinship and descent and alliance, those instincts don't disappear just because we live in a world with population genetics and genomic sequencing. They get redirected, they find new objects, and when something as concrete and visible as blood enters the picture, something that can be typed and measured and assigned a letter and a positive or negative sign, those ancient instincts have something fresh to attach to. To understand why bloodline myths feel so compelling, it helps to think about what they actually offer the people who find them persuasive. They offer belonging, for one thing. The sense that you're connected to something larger and older than yourself, that your identity is not just an accident of birth in a particular town to particular parents, but rather the expression of a lineage that stretches back through centuries or millennia, through famous ancestors or legendary peoples or even something beyond the human altogether. That's a powerful feeling. It answers questions that ordinary secular life often leaves unaddressed. Who am I? Where do I come from? Why do things feel the way they do? They also offer meaning, not just any meaning, but the specific kind of meaning that comes from being part of a pattern. The idea that your unusual blood type is not a random outcome of inheritance, but a marker, a signal, evidence of something that the mainstream world has either failed to notice or chosen to suppress. That your rarity is purposeful, pointing towards something important about your nature or your destiny. That's not a small thing to offer someone. It's actually quite generous, in the way that a very appealing story is generous, regardless of whether it's true. And they offer status. This is perhaps the most honest piece of the psychology, because humans have been attaching status to blood for as long as we have written records, and almost certainly long before that. The idea of noble blood, of blood that confers rank and privilege and inherent superiority, is not a fringe notion. It was the foundational organizing principle of most of the civilizations that dominated human history for thousands of years. In medieval Europe, the distinction between noble and common was treated not as a social arrangement, but as a biological reality. Noble families were understood to carry something different in their blood, something that justified their position, their power, their right to rule and own land and demand deference. The language of blood became the language of class, and that language was enforced with remarkable thoroughness. You could be executed for claiming noble descent you didn't possess. You could be excluded from guilds, from universities, from offices, from marriage prospects, based on the perceived purity or impurity of your ancestral blood. This wasn't confined to Europe. Across cultures and centuries, blood served as the vocabulary through which societies talked about inheritance, about who counted, about who belonged. In Spain during the era of the Reconquista and the Inquisition, the concept of limpieza de sangre, cleanliness of blood, was used to distinguish those of purely Christian ancestry from those with Jewish or Moorish heritage, regardless of what the individuals themselves believed or practiced. Blood was evidence, blood was destiny, blood was a record that the body kept whether you wanted it to or not. Later, when nationalism emerged as the dominant political form of the modern era, blood metaphors followed. Nations were spoken of as having blood, shared blood, common blood, blood that could be polluted or preserved, blood that tied people to soil and tradition and collective memory. The language of ethnic nationalism is saturated with blood imagery even when it isn't talking about biology directly, because blood had become such a deeply embedded metaphor for everything that inheritance was supposed to mean. None of this is benign history. Much of it caused tremendous suffering, but it is important background for understanding why the combination of a measurable blood characteristic and a story about ancient origins and secret lineages lands so easily in human imagination. The conceptual slots were already there, worn smooth by thousands of years of use. Whereas negative blood didn't create the idea of bloodlines carrying special significance. It simply moved into a template that human cultures had been elaborating for millennia. There is a particular storytelling pattern that makes this move almost inevitable, and it goes like this. Something is identified as rare. Rarity in common experience usually signals value, so the next step is to interpret the rarity as meaningful. Meaningful rarity, in a world where meaning tends to be organized around stories, becomes evidence of special origin, special purpose, special nature. From rare to special is a short step. From special to chosen, or ancestral or other, is barely any step at all. The story practically tells itself, and it tells itself with particular ease when the rare thing is something as intimate and invisible as blood type. You cannot see your own blood type in any ordinary moment of your life. It's something you're told, something that exists in documents and databases and the memory of a blood drive you attended years ago. That invisibility makes it available for meaning in a way that more visible traits are not. It can be a secret marker, something others don't know about you, something that might explain things that otherwise feel unexplained. The quieter and more private a characteristic, the more easily it becomes a vessel for significance that has nowhere else to go. This is where the gentle correction becomes necessary. Not to dismiss the impulse, not to mock the people who find bloodline stories compelling, but simply to notice what the biology actually shows. Because rarity in biology is common. This sounds paradoxical, but it's straightforwardly true. The human genome contains millions of sites where variation exists, where one group carries one version of a sequence and another group carries a different version, where frequencies shift across populations, where particular variants are common in some places and nearly absent in others. Almost none of this variation is considered mystical. Almost none of it becomes the basis for a theory about ancient origins or hidden lineages. It is simply the expected texture of a species that has been moving across the planet and diverging and reuniting and diverging again for hundreds of thousands of years. Rh-negative status is one node in that vast landscape of variation. It is genuinely less common than Rh-positive status in most human populations. That's real. But uncommon is not the same as otherworldly. Uncommon is not the same as ancient and separate. Uncommon is not the same as chosen, or royal, or visited by something beyond ordinary human inheritance. The biology simply does not go there. What it goes to instead is drift, and founder effects, and the particular demographic history of populations that moved through particular bottlenecks and expanded in particular directions and mixed with particular other groups at particular moments. The story is genuinely fascinating. It just doesn't require a secret. What's worth noticing is how consistently the myths reach for status and belonging, when the facts themselves offer something arguably more profound, which is the sense of genuine connection to a human story so long and so complicated that no single bloodline could contain it. Every Rh-negative person alive today is the product of the same vast history as every Rh-positive person alive today. The same migrations, the same bottlenecks, the same desperate crossings of ancient landscapes, the same moments of interbreeding between populations that had been separated for tens of thousands of years. Blood types are one faint echo of all of that, but the full story is louder and stranger, and in every meaningful sense more remarkable than any secret lineage has ever managed to be. Of all the specific myths that have attached themselves to Rh-negative blood, the one about royal lineages is perhaps the most elaborately developed. You encounter it everywhere on the internet, in forums and comment sections and documentary-style videos with dramatic music and slow zoom effects on old portraits. The claim takes various forms, but the core of it is usually something like this. Rh-negative blood is unusually prevalent among the royal families of Europe. The Basques, who have some of the highest rates of Rh-negative blood in the world, are somehow connected to ancient ruling classes. Certain dynastic lines, the Habsburgs, the Merovingians, the British royal family, various pharaonic lineages, depending on which version you're reading, carried Rh-negative blood as a defining feature, a biological marker of their right to rule, evidence that their ancestry was distinct from that of ordinary people. Some versions of the story stop there and treat it as historical curiosity. Others extend it into something stranger, suggesting that these dynasties knew what their blood meant, that they intermarried specifically to preserve it, that they were in some sense managing a genetic heritage whose true origins they understood, and the rest of us do not. It's worth sitting with that for a moment, not because it's convincing, but because it is genuinely seductive in the way that well-constructed stories tend to be. It takes real things, actual royal dynasties, actual patterns of intermarriage, actual high rates of Rh-negative blood in certain populations, and it connects them into a narrative that feels like it's revealing something hidden in plain sight. That's a particular kind of storytelling pleasure, and before going any further, it's worth being clear about what real history and real genetics can and cannot tell us about all of this. The first thing to understand is that we almost never know the blood types of historical figures. This is not a minor technical limitation. It is a fundamental constraint on every claim in this category. Blood type is a property of living cells. It can sometimes be inferred from ancient DNA if the preservation is exceptional and the analysis is careful and the sample hasn't been contaminated over centuries or millennia of burial. But for the vast majority of historical individuals, including most royals, most nobles, most famous people from any era before the 20th century, we simply have no idea what their blood type was. The records don't exist, the samples aren't available. The claims, when you trace them back, are typically sourced to other internet posts, which are sourced to other internet posts which eventually lead nowhere reliable at all. This is what historians mean when they talk about evidence. Not just the feeling that something is probably true, not the internal logic of a theory, but actual documentation, actual data, actual remains that can be tested and verified and checked against competing explanations. The claim that European royals were disproportionately Rh-negative is not drawn from a database of tested royal samples. It is drawn from assumption, from the idea that because certain populations with high Rh-negative rates, particularly Basque populations, were geographically connected to the regions where European royal dynasties operated. Therefore, those dynasties must have shared the trait. That's not evidence. That's a story that sounds like evidence. What we do know about royal intermarriage in European history is genuinely interesting, but it tells a very different story. The ruling families of medieval and early modern Europe intermarried with obsessive frequency, not because they were managing a bloodline in the genetic sense, but because marriage was the primary instrument of political alliance and territorial consolidation. A marriage between a Spanish princess and an Austrian archduke was a contract between states. It created obligations, neutralized enemies, secured borders, and occasionally produced heirs who would rule both territories. The Habsburgs in particular became famous for this strategy, accumulating kingdoms and principalities through generations of strategic unions, until their family tree had more loops in it than a Celtic knot. The genetic consequences of this were real and visible, and they were not flattering. The famous Habsburg jaw, the protruding lower lip and chin that appears across centuries of portraits, was a textbook example of the effects of inbreeding on dominant genetic traits. Charles II of Spain, the last of the Habsburg line, was so severely affected by the compounded effects of centuries of close relative marriage that he was unable to chew his food properly and died without an heir at the age of 38. His autopsy reportedly noted that his body contained almost no blood, and that what there was appeared to be corrupted. The lesson that history actually offers from royal intermarriage is not about the preservation of something special. It is about what happens when any population reduces its genetic diversity through systematic endogamy. Recessive conditions become more common. Genetic disorders accumulate. The very practice that was supposed to preserve the purity and power of a dynasty tended over generations to undermine the physical health of the individuals it produced. If there were any conscious awareness among royal courts of blood types as something to be managed, the last thing it would have recommended was the practice those courts actually followed. What makes the Rh-negative royal myth particularly interesting from a psychological standpoint is the way it inverts this real history. The actual story of royal intermarriage is largely a story of political calculation, religious obligation, and unintended genetic consequence. But the myth reframes it as intentional biological stewardship, as if the people arranging these marriages understood something about heredity that the rest of the world would not grasp for centuries, as if the inbreeding was not short-sighted dynastic politics but a sophisticated program for maintaining a distinct lineage. The same set of facts read through different lenses produces entirely different narratives. What the evidence actually supports is one. What the myth requires is the other. Pedigree myths of this kind flourish most vigorously when documentation is scarce or ambiguous, and this is not an accident. When the historical record is thin, when evidence is hard to obtain or verify, there is space for interpretation, and that interpretive space gets filled by the stories that feel most satisfying rather than the ones that are most defensible. The same dynamic operates in family genealogy, where the lines of descent that can be traced reliably for a few generations give way, at a certain point in the past, to legend and wishful reconstruction. Somewhere in many family trees there is a rumoured connection to royalty, or a supposed ancestor of unusual distinction, inserted at exactly the point where the records become too sparse to contradict it. Royal blood flows most freely through the parts of history where nobody can check. The right question to ask of any lineage claim is not whether it feels plausible, but what would actually count as evidence for it, and whether that evidence exists. For the claim that Rh-negative blood marked European royal dynasties, the evidence would need to include reliable testing of remains from those dynasties, statistical comparison with contemporary non-royal populations of similar geographic origin, and some plausible mechanism by which blood type could have influenced marriage selection in an era when blood typing did not exist as a concept. None of those conditions are met. The claim is not waiting for further research to confirm it. It is a story that has already outrun its evidence by several centuries. None of this diminishes the genuine strangeness of actual royal history, which is strange enough without any embellishment. The political marriages, the accumulated disorders, the elaborate rituals around blood and lineage and dynastic continuity, the way that ordinary people across centuries were taught to regard certain families as being of a different and elevated nature. All of that is real, documented, and in its own way remarkable. The obsession with blood was real, the consequences were real, the belief that certain bodies carried something different was real, and was enforced with tremendous social force. That history deserves to be understood on its own terms. What it doesn't need is a layer of genetic mythology laid over it, especially one that can't be verified, that collapses under scrutiny, and that ultimately says less about royal history than it does about our ongoing, very human hunger for stories in which blood means more than biology. From the question of royal dynasties, it is only a short distance to something stranger. The myths don't stop at medieval courts and Habsburg jaws. They keep going, and going, until they reach places that medieval scribes and court genealogists would have found baffling. Because somewhere in the long strange history of Rh-negative mythology, the story stopped being about kings and started being about something else entirely, about beings that were not quite human, about interventions from beyond the sky, about ancient texts and alien architects and a bloodline that didn't begin anywhere on this planet. This is the territory where the myths become genuinely elaborate, where they develop their own internal logic and their own communities and their own vocabulary. And it's worth spending some time here, not to ridicule anyone who has found these ideas compelling, but because the stories themselves are interesting as stories, and understanding how they were built is more illuminating than simply dismissing them. The Nephilim appear in the Book of Genesis briefly, in a passage that has troubled and fascinated interpreters for thousands of years. The text describes beings called Nephilim, often translated as giants or fallen ones, who were the offspring of unions between the sons of God and the daughters of men. They were described as mighty, as men of renown, and then the text moves on, leaving everything about them unexplained. Who were the sons of God? What exactly happened? What became of the Nephilim? The ambiguity is total, and ambiguity is where interpretation flourishes. For most of the history of biblical scholarship, the Nephilim passage was read as mythology, as narrative, as part of the antediluvian world that Scripture describes before the flood, not as literal genetics. But in the 20th century, particularly in the proliferating world of alternative history and fringe archaeology, the Nephilim began to acquire a more literal reading, and that reading eventually acquired a blood type. The argument in its most common form runs something like this. Rh negative blood cannot be explained by normal evolutionary processes. Because it doesn't appear in other primates, it must have originated from somewhere else. The Nephilim, or the Anunnaki, or the Elohim, depending on which tradition the storyteller draws from, were extraterrestrial beings who interbred with early humans. Rh-negative blood is the genetic trace of that interbreeding, persisting across millennia in certain human populations, marking the descendants of that ancient contact. Some versions of the story are more explicitly science-fictional, drawing on ancient astronaut theories popularized by writers like Erich von Däniken in the 1970s, who argued that ancient monuments and mythological traditions were evidence of extraterrestrial visitation. Others keep closer to a scriptural vocabulary, treating the Nephilim as real historical beings whose genetic influence can still be detected in living people today. It is a remarkable piece of narrative construction. It takes an actual scientific fact that Rh negative blood is absent in non-human primates, and it builds from that fact a story that is internally consistent, emotionally resonant, and almost entirely disconnected from how science works. Because the absence of something in other species is not evidence of alien origin, it is evidence of mutation and evolutionary divergence, which is exactly what population genetics describes when it examines the RhCE and RhD genes, their distribution across human populations, their appearance as variants in a lineage that has been evolving on this planet for millions of years. The gap between a real scientific observation and the conclusion the myth draws from it is not a small one. It is the entire distance between evidence-based reasoning and storytelling. What the myth requires, if it were to be taken seriously as a scientific claim, is enormous. It would need to account for why alien or semi-divine genetic contribution would express itself through a single protein marker on red blood cells, while leaving every other aspect of human biology, every other gene, every chromosome, every metabolic pathway, essentially unchanged. It would need to explain why the frequencies of Rh-negative blood vary so smoothly across geography, with the highest rates in certain European and Basque populations and declining frequencies moving east, exactly the pattern you would expect from a founder mutation spreading through human populations by ordinary inheritance, and exactly the opposite of what you would expect from a geographically scattered divine intervention. It would need to account for the detailed molecular biology of the Rh system, which has been mapped comprehensively, which shows the specific mutations involved, which reveals the ancestral and derived forms of the genes in a sequence that follows the logic of terrestrial evolution with no gaps that require filling by anything beyond normal biology. None of these requirements are met, and this is not because the science is hiding something. It is because the science has looked very carefully and found a clear, coherent, unsensational story. And the myth was built by people who either hadn't read that story or had decided in advance that it wasn't the one they wanted. What's genuinely interesting about the alien and Nephilim theories, when you approach them with curiosity rather than contempt, is the cultural genealogy they carry. These are not ideas that appeared from nowhere. They are built from layers of material that have been accumulating for a long time. Ancient scriptural texts provided the raw vocabulary, the Nephilim, the sons of God, the idea of divine human interbreeding. Mid-20th century pulp science fiction provided the conceptual framework. Aliens as the new gods, ancient contact as explanation for human origins and ancient monuments. The alternative history literature of the 1970s and 80s, von Däniken, Zechariah Sitchin's interpretations of Sumerian texts, Graham Hancock's geological speculations, provided specific narrative content that felt scholarly in its presentation even when it departed significantly from mainstream archaeology. And then the internet provided the infrastructure. Forums and comment threads and video channels where all of these influences could combine, recombine, be passed from user to user and modified in each retelling, accumulating detail and internal consistency over years of collaborative elaboration. The result is something that functions less like a theory and more like a mythology in the proper sense, a story that a community shares that provides a framework for understanding one's place in the world, that creates a sense of connection to something larger and more significant than ordinary life. People who believe they carry Nephilim blood, or who identify themselves as starseeds or hybrids, or ancient lineage holders, are not simply making an empirical claim about their red blood cells. They are participating in a community, finding meaning in a shared narrative, experiencing the particular pleasure of feeling that one's own body is a marker of something extraordinary. That is a genuinely human need, and dismissing it without acknowledging it misses something important. The wonder that people bring to these stories, the sense that there is something mysterious and significant about existence, that ordinary appearances may conceal deeper patterns, is not wrong in itself. It is in fact the same impulse that drives good science, the conviction that the world is stranger and more complex than it seems on the surface, that careful attention will reveal things that casual observation misses. The problem is not the wondering. The problem is when a particular story closes itself off from the kind of scrutiny that would let it be corrected. Real archaeology and real genetics are extraordinarily good at detecting the unusual. Ancient DNA analysis can reconstruct population movements from tens of thousands of years ago. Genomics can identify which variants of which genes arrived in which populations at which points in history. If there were a genuine discontinuity in human genetic history, a true break that required explanation beyond known evolutionary processes, these tools would find it. They have found the interbreeding between modern humans and Neanderthals. They have found the Denisovan contribution to modern Asian and Oceanian genomes. They have found the traces of population bottlenecks and migrations and founder effects stretching back hundreds of thousands of years. What they have not found is anything that requires a non-terrestrial explanation. The renegative distribution fits within the known story of human migration and mutation. There is no signal in the data that points outward, off the planet, into mythology. The myths persist not because the evidence supports them, but because no evidence could fully dislodge them. They are structured to absorb contradiction, to treat scientific consensus as itself suspicious, to read the absence of proof as proof of concealment. And that structure, more than any specific claim within it, is what marks them as mythology rather than hypothesis. Mythology doesn't need to be true to be meaningful, but it does need to be understood as mythology, which is what it is, assembled from scripture and science fiction and human longing, and worth understanding on those terms rather than any other. So now you understand the mythology, you understand where it came from, what it is made of, and why it functions the way it does. But there is still a question worth sitting with, because understanding the content of a false belief is different from understanding how it travels. How does a story that begins in a fringe forum or a late-night video channel end up feeling, to a significant number of people, more credible than a peer-reviewed paper? How does misinformation spread And more importantly, why does it feel true when it arrives? The mechanics are not mysterious, though they are worth naming clearly. Algorithms built by large platforms are optimized for engagement, and engagement is not the same thing as accuracy. Content that provokes curiosity, that offers a revelation, that promises to show you something hidden, performs extremely well by the metrics that platforms use to decide what to show you next. So when someone watches one video suggesting that Rh negative blood has an unusual origin, the next video they are offered tends to be one that goes further, that adds more detail, that makes the claim more elaborate and more dramatic. Not because the platforms intend to spread misinformation, but because the algorithm cannot distinguish between the excitement of genuine discovery and the excitement of a well-constructed conspiracy narrative. Both generate the same behavioral signal, both keep you watching. Repetition does the rest. There is a well-documented psychological effect, sometimes called the illusory truth effect, in which repeated exposure to a claim increases the feeling that the claim is true, independent of any evidence for or against it. Familiarity feels like recognition. Recognition feels like confirmation. By the time someone has encountered the idea that Rh-negative blood might be extraterrestrial or otherworldly in a dozen different videos, articles, forum posts and comment sections, it has accumulated a weight that a single scientific paper, no matter how thorough, struggles to counterbalance. The paper is new, the idea is old, and old feels settled. Then there is the rhetorical strategy known, sometimes affectionately, sometimes not, as just asking questions. It is a particularly effective technique because it presents itself as intellectually humble, as open-minded, as merely inviting inquiry rather than asserting anything. A video that says Rh, negative blood is definitely from aliens, makes a claim that can be directly evaluated and found wanting. A video that asks, have scientists really explained where Rh negative blood comes from, or why won't mainstream researchers address these anomalies, is doing something harder to pin down. It implies that the question is unanswered without having to defend that implication. It gestures at a gap without having to locate the gap precisely. And because science does involve genuine uncertainty, because scientists are genuinely cautious about overstatement, because the honest answer to many questions involves probabilistic language and conditional clauses, this uncertainty gets harvested and repackaged as something else entirely, as evasion, as suppression, as evidence of a cover-up. Scientific uncertainty is not a cover-up, it is how science actually works. When a geneticist says the precise timing of the mutation that created the Rhd negative variant is not yet fully established, they are being honest about the limits of current data. They are not protecting a secret. They are describing the frontier of knowledge, where the work is still being done and the answers are still being refined. But the careful honesty looks from the outside if you have been primed to look for concealment, exactly like what concealment looks like. The misinformation ecosystem has learned to exploit this. Uncertainty is framed as incompleteness. Incompleteness is framed as hiding. Hiding is framed as proof that there is something to hide. There are some practical signs worth learning to recognize, not because you need to become a professional fact-checker, but because a few simple habits of attention make a significant difference. Fake or misused citations are common. A claim will reference a real study with a real author and a real journal, but the study will not say what the claim says it says. The study might be about something adjacent, might be years out of date, might have been retracted, or might in fact contradict the claim being supported by it. The fix for this is straightforward and requires no expertise. Find the original source, read the abstract, see whether it matches what the claim says about it. Most of the time, if the citation is being abused, the mismatch is obvious even to a non-specialist. Moving goalposts are another reliable signal. When a specific claim is addressed and found to be false, does the discussion engage with that correction, or does it simply shift to a new claim of the same type? The alien blood theory has been doing this for decades. When the genetics of the Rh system were mapped comprehensively, and the evolutionary lineage of the relevant genes was traced in detail, the response was not to revise the theory. The response was to say that mainstream genetics itself was untrustworthy, that the studies had been conducted by researchers with something to hide. The claim moved. It kept its shape but changed its location, always retreating to ground that had not yet been directly examined. This is not how genuine inquiry behaves. Genuine inquiry follows the evidence where it leads, including when it leads to revision. But perhaps the most important thing to understand about why misinformation feels true is what it offers emotionally. Because this is not a story primarily about logic. It is a story about what it feels like to possess secret knowledge, to have seen through the official account, to belong to a community of people who understand something that others have missed or been prevented from seeing. There is a deep human pleasure in that feeling. It provides identity. It provides a sense of agency in a world where much feels outside our control. It provides the particular comfort of meaning, the sense that things which seemed random or arbitrary are actually structured, that patterns run beneath the surface, that your own blood, the fluid that moves through you every moment of your life, connects you to something larger than ordinary history. These are not trivial satisfactions, they meet real needs. The problem is that they can be met by false things just as easily as by true ones. The emotional payoff of a compelling myth does not depend on whether the myth is accurate, and this is why approaching these questions with contempt is both unkind and strategically unhelpful. People who find meaning in the alien bloodline narrative are not, in most cases, simply credulous or foolish. They are people looking for wonder and significance in a world that often feels impersonal and opaque. The instinct itself is good. What matters is where it is directed. Practical media literacy is not about becoming a cynic. It is not about treating everything as suspect or reading every source with hostility. It is much simpler than that. It is about noticing the difference between sources that update when new evidence arrives and sources that do not. Between claims that engage with counter-evidence and claims that dismiss it. Between communities that allow members to change their minds and communities that treat revision as betrayal. Science is not perfect, and scientists have been wrong, sometimes badly wrong, about important things. But science has mechanisms for correcting itself. Misinformation ecosystems, by design, do not. That asymmetry is the most reliable thing to watch for. The story of Rh-negative blood is a useful case study precisely because the scientific account is genuinely interesting. The real genetics, the real population history, the real evolutionary story of how a mutation in a single gene family spread through human populations across tens of thousands of years is full of the same qualities that the myths are reaching for. Complexity, deep time, strangeness. The sense that ordinary things carry extraordinary histories inside them. None of that required invention. It was already there, in the data, in the fossils, in the molecules, waiting to be read, which is what the science quietly and without drama has been doing all along. So let us come to it directly, without fanfare, because the real story does not need any. Rh-negative blood is a normal feature of human genetic variation. It is not an anomaly. It is not an error. It is not evidence of ancient intervention or lineage outside the human family. It is what happens when a particular version of a gene, a version that arose through ordinary mutation at some point in the deep past, becomes established in certain populations and not others, spread or constrained by the same forces that shaped every other trait that makes us genetically diverse. Migration patterns, founder effects, genetic drift in small populations, occasional selection pressures that researchers are still working to characterize fully. These are the mechanisms. They are well understood in their general shape even where specific details remain open questions. The RHCE and RHD genes sit on chromosome 1. They are closely related, products of an ancient duplication event, and the RHD negative variant in most cases reflects the absence, or disruption, of the RHD gene, rather than the presence of something new. You're not carrying something extra if you are Rh negative. You're carrying a variant in which a particular genetic sequence is missing or non-functional. That is not a diminishment. It is simply a different configuration, one that has persisted across human populations because it has not imposed a strong enough disadvantage to be eliminated by selection, and may in some contexts have carried neutral or marginal benefits that kept it in circulation. This is unremarkable by the standards of population genetics. Human genomes are full of variants like this, differences in what is present or absent, active or silent, that carry no grand significance and no mysterious origin. The population distribution of Rh-negative blood is genuinely interesting, though, and mainstream science has never hidden this interest. The concentrations found among Basque populations, among certain North African groups, and the relative rarity across East Asia and Sub-Saharan Africa are patterns that population geneticists have been studying and writing about openly for decades. The working explanations involve the particular isolation history of the Basque people, whose genetic profile suggests they descend in significant part from populations that were present in Europe before the great waves of migration from the Near East that accompanied the spread of agriculture. Their gene pool preserves variations that were diluted elsewhere by incoming populations. The Rh negative frequency they carry is probably a relic of that pre-agricultural European ancestry, not a sign of anything else. Other elevated frequencies in other regions have their own explanations, some more thoroughly mapped than others, but all operating within the same framework of population movement, isolation, mixing, and drift. What mainstream science says about all of this is not hidden. It is published in journals, summarized in textbooks, discussed in university courses, and accessible to anyone who wants to read it. The mechanisms behind hemolytic disease of the newborn, the way Rh incompatibility between mother and fetus can trigger an immune response, the development of Rh immunoglobulin as a preventative treatment, the population patterns and their evolutionary context, all of it is in the literature, described in plain enough language that a curious non-specialist can follow the argument. The reason it may feel less available than the conspiracy version is not suppression. It is that scientific papers do not optimize for emotional intensity. They are written to be precise, not to be gripping. They do not promise revelations. They present evidence, describe uncertainty, and invite further study. That is a different kind of reading experience, and it can feel, in comparison to a breathlessly narrated video, as though it offers less. It does not offer less. It offers more carefully. The open questions are worth naming honestly, because they are real, and the honest answer to them is not that science is hiding something, but that science is still working. The precise timing of when the Rhd negative variant first arose, and in which population, is not yet established with certainty. The question of whether there have been any selective pressures favouring or disfavouring the variant in specific environmental contexts is still being explored. The full picture of how Rh negative frequency has shifted across populations over time as ancient DNA analysis becomes more refined is an ongoing area of research. These are frontiers. They are places where the data is incomplete, where methodologies are still being developed, where conclusions are provisional and appropriately hedged. None of this is concealment. It is the normal texture of scientific work at its edge, where certainty shades into probability, and probability shades into open questions that future researchers will spend careers trying to resolve. The genuinely strange thing about biology is that it does not need embellishment. The strangeness is already present in the actual facts if you sit with them long enough. The molecule at the center of this story, the Rh protein complex embedded in the red blood cell membrane, is a structure that has been conserved across an enormous range of living things. Versions of it appear in organisms separated from us by hundreds of millions of years of evolution. The fact that our blood cells carry proteins whose architecture echoes structures found in organisms that existed before complex animals existed at all, that our bodies still use molecular machinery, that old is more genuinely extraordinary than anything the alien bloodline theory has to offer. There was no need to invent a supernatural origin. The deep evolutionary history of these molecules is strange enough, and it is real. What the real truth looks like is this. Somewhere in the past, in a population whose location and size we can only approximate, a mutation altered or eliminated the Rhd gene in an individual, or perhaps in several individuals across related populations. That variant was passed to children, and their children, across thousands of years and thousands of miles, carried in the blood of people who built settlements and buried their dead and learned languages and mixed with neighbouring groups, and sometimes were isolated for long enough that the frequency of the variant changed in ways that still show up in our genetics today. Those people were fully human in every sense. They had the same fears and the same hungers and the same capacity for wonder as the people in whom a functional Rhd gene persisted. Their blood was not a mark of special origin. It was one thread in the immense, complicated fabric of human variation, a fabric that is itself far more intricate and beautiful than any simple story about bloodlines and origins can capture. The ancient symbolism of blood as life and soul and sacred substance was not wrong to sense that something extraordinary runs through us. It was reaching, through the only instruments available to it, toward a truth that science would eventually describe in molecular terms. The Egyptians who drained blood in sacred rites, and the medieval physicians who bled their patients, and the early transfusionists who killed their subjects trying to understand what blood did, were all, in their different ways, trying to read something that was genuinely there to be read. They did not have the tools to read it accurately. We have better tools now. They do not disenchant the subject. They reveal that the subject was always deeper than the myth supposed. You do not need a conspiracy to make blood strange. You do not need alien ancestry to make your own biology worth marvelling at. The real history, the actual molecular history, the population history, the evolutionary history that runs back through the Basques and the pre-agricultural Europeans, and through every migration and bottleneck and isolation event that shaped our species, is long enough and complicated enough and full enough of genuine mystery that wonder is simply the correct response to it. The strangeness was always real. It just does not belong to anyone in particular. It belongs to all of us, in whatever form our blood happens to carry. And so we find ourselves at the end of a very long journey. We began with the oldest human intuition, the sense that blood was not simply a fluid, but a carrier of something essential, something sacred, something that connected the living to the dead and the individual to the community. We moved through the ancient world where priests and physicians alike treated blood as the most significant substance a body contained, where its spilling was ceremony, and its presence was life, and its absence was a kind of erasure. We followed the slow, often painful history of science trying to understand what blood actually was, through the humoral theories that dominated for centuries, through the extraordinary discovery of circulation, through the catastrophic early experiments in transfusion that killed patients and discredited the entire enterprise for a generation, through the eventual unlocking of the ABO system that made transfusion safe and saved millions of lives across 2 world wars and every surgical theatre that followed. And then we found the Rh factor, discovered almost by accident, named after the wrong animal, immediately complicated by the terrible human drama of hemolytic disease in the newborn, and eventually unravelled by science carefully enough that the condition it causes became almost entirely preventable. We traced the genetics down to the chromosome level, to the closely linked RHCE and RHD genes, and the variants that determine whether a person carries that D antigen or does not. We mapped the curious distribution of Rh-negative blood across human populations, the striking concentrations among the Basque people, the elevated frequencies across parts of North Africa and the Middle East, the relative rarity across East Asia and Sub-Saharan Africa, all of it explicable within the framework of population history, migration, isolation, founder effects, and the ordinary mechanisms of how genetic variation moves through time. We passed through the mythology that has grown up around all of this, the stories of royal blood and divine right that used bloodline as metaphor and then, over time, began to treat the metaphor as biology. The more recent claims about Rh-negative individuals as remnants of an ancient hybrid lineage, descendants of the Nephilim or of extraterrestrial visitors, carriers of some special quality that sets them apart from the rest of humanity. We looked at how those stories spread, why they feel compelling, what they offer to the people who find comfort or identity in them, and why the mechanisms of social media make emotionally resonant claims so much more contagious than careful, hedged, peer-reviewed ones. And then we came to what the evidence actually shows, which is not a diminishment but an invitation. An invitation to find the genuine strangeness of your own biology more interesting than any invented version of it. Your blood, whatever type it happens to be, whatever combination of antigens your red cells carry, is a record. It contains information about where your ancestors lived, and who they lived near, and when they moved, and which populations they mixed with, and which ones they stayed apart from, long enough to preserve the particular configuration of variation that eventually produced you. The ARC proteins embedded in your cell membranes are ancient structures, conserved across evolutionary time, part of molecular machinery that has been doing its work for far longer than our species has existed. There is nothing ordinary about that if you let yourself sit with it. The ordinariness is only in the explanation. The thing being explained remains extraordinary. If this episode found you somewhere quiet, somewhere near the edge of sleep, somewhere in that comfortable drift between attention and rest, then it has done what these episodes are meant to do. History is not only for the bright and alert hours. Some of it lands differently in the dark. when the mind is softer and less defended, when the long timescales start to feel less abstract and more like something you can almost touch. If you enjoyed the journey tonight, the kindest thing you can do is very simple. Leave a like if you found something here worth your time, subscribe so that the next episode finds you without you having to go looking for it, and leave a comment, even a short one. We would genuinely love to know where in the world you are listening from tonight. Whether you're in a bedroom in Edinburgh or a studio apartment in Chicago or somewhere entirely unexpected, that small geography of where these stories land is something we find quietly wonderful to know. Every comment also helps more people find their way here, which means more quiet nights and more curious minds and more of this strange, long, thoroughly human history getting told. If your curiosity about the deep past did not settle itself fully tonight, there is more waiting for you at sleepytimehistory.com. Alongside the episodes, we have a book about prehistoric secrets, about the long and complicated and often astonishing story of what came before the written record, before the monuments, before the cities, in the time when our ancestors were making their way through a world that was genuinely difficult and genuinely beautiful and full of pressures that shaped everything we eventually became. The kinds of events we touched on tonight, the ancient population movements, the isolated communities, the genetic signatures that still show up in living people and tell us something about who survived and how, that territory is explored at much greater length in the book, and if it sounds like the kind of company you would enjoy, you will find it there. For now, though, let the questions rest. There is no urgency here. The history of your blood is not going anywhere. The genes on chromosome 1, the ancient proteins in your cell membranes, the migration routes of your distant ancestors across continents you will never walk, all of it will still be there when you wake. You are carrying it with you, as every person who has ever lived has carried the long record of what came before them, quietly, without knowing most of it, in the ordinary and extraordinary machinery of a living body. So let the weight of the day settle a little further. Let the questions become gentle background rather than urgent foreground. Whatever your blood type, wherever you are listening from, however far or close to sleep you happen to be, you are part of the same long story that we have been tracing together tonight, and that for now is enough.